All right, folkies, today is proportions, proportions, and more proportions. We've been doing those for a while, and we're going to continue to do those for a while. So I want to, first of all, take you back to when we worked on proportions with geometry, and then we're going to move into the word problem proportions. So remember when we looked at figures, we would make sure, I said quite often, make sure you keep everything consistent. Like this is the left side, and then this is the bottom. So if I do 14 over 8, so if I go 14 to 8, then on the other side I have to go 6 to x. The key is to keep everything consistent. I like to go wherever my x is first. So 14x equals 8 times 6, and I believe that is 48. Now that we've got our 8 times 6, we're going to divide both sides by 14. Remember, what we do to one side, we do to the other. And x equals, when you divide that, I got 3.4, and there's a lot of decimals. I'm just going to put 3.4 for now. So that is what we were looking for. What is x? What belongs in this position? Okay. So now we're going to look at word problems. So we've got Arturo reads 410 words in 15 minutes. How many words will he read in 92 minutes? There's lots of different ways to solve this, but we're going to stick with proportions because I hope that that's getting pretty familiar and easy to us by now. We need to focus on what two key things are we talking about. We're talking about words and we're talking about minutes. Now, what I always ask my mathematicians to do is make a little note over to the side what order you're going to use. So if I'm comparing words to minutes, then on my other side I need to also compare words to minutes. Okay, so this side needs to be in the same order. So if I do 410 words to 15 minutes, then on the other side it says how many words will he read in 92 minutes. So the minutes has to go on the bottom because that's where minutes is on the other side. So this is kind of like a puzzle. So we put all the pieces in the right place, and then the piece that's left is our x. I'm going to go to my variable first. So I've got 15x equals, and I'm going to punch in 410 times 92, 37,720. Now we're going to divide both sides by 15. And x equals 2,214 point. There's a whole bunch of sixes, so I'm going to round to 0.7. Okay, remember the key is to keep it consistent. Words and minutes, words and minutes. So now if we look at another one, we got a recipe uses 3 cups of sugar to make 48 pieces of taffy. How much sugar would you use to make 72 pieces of taffy? So again, we're going to use a proportion, and we're talking about cups of sugar and pieces of taffy. So 3, and you could put cups or you could put sugar. I'm going to put cups, and 48 pieces of taffy. So I'm only putting this over here just so that I remember the order that I'm using. So if I'm looking at 72 pieces of taffy, the pieces has to go on the bottom, and this is going to be our x. Had the question have been asking us about cups of sugar, then the cups of sugar would have gone here, and then the x would have been for the pieces. It just depends on what it's asking us. So 48x equals 72 times 3. I believe that's 216. Okay, so we're going to divide both sides by 48. Slide this up just a pinch. And x equals 4.5. So that means that we would need 4.5 or 4.5 cups of sugar if we wanted to make 72 pieces of candy. So this is telling us how much sugar that we would need. Okay, just a couple more. if 96 inches is in 4 feet, if 96 inches is in 8 feet, how many inches in 15 feet? Again, lots of different ways to solve this. Gracious, we got blurry. Sorry about that. So now 96 and 8. So I'm talking about inches and I'm talking about feet. And then it says 15 feet. So then this means this is going to be my x. Now x, these particular problems, x has fallen in the top every time. That's not going to always be the case. Remember, it just depends on how we start. I could have started feet over inches, and then this side would have had to be feet over inches. The key is keeping it consistent. So we got 8x equals 96 times 15, 1,440. Divide that by 8. Yay, one that finally ended up not being a decimal. So we got 180. So we're going to look at 180 inches, is that's what it's telling us, 180 inches in 15 feet. Okay? One more that's a little more complicated, not quite as straightforward. Okay, a building has a shadow that is 15 feet long. Jackie's shadow is 3 feet long and she is 6 feet tall. How tall is the building? So we need to think about, I don't like to start with the building because we don't have everything that we need to know about the building. I like to start with Jackie. Now remember, there's lots of different ways to do this. It makes sense to me to start with Jackie because we've got the 3 feet long and the 6 feet tall. We've got all the information we need. So we're looking for long and tall. So if I do 3 feet long and 6 feet tall. Now if I go back up here, it says that the building is 15 feet long. So that means long has to go on top. And then this is going to be x. So 3x equals 15 times 6, 90. Divide both sides by 3, and I believe that's going to be 30. And so that means that the building is 30 feet tall, because that's where our x is. So that's telling us the building is 30 feet tall. So again, not that difficult. Just the key is to make little notes over to the side, because if you get these numbers mixed up, then obviously you're going to get the wrong answer. So make sure you put little notes over to the side. It only takes a second, but a lot of times that's going to save you a lot of heartache in the end. So take the time, write that down, and solve some proportions. And remember, we're going to be doing this for a while, so we want to get really, really good at it, because our end of grade test is going to be, a good chunk of it is going to be these types of questions. So we need to get where we are really proficient at it. So I hope y'all have a great day. Contact me if you need me.